Part, we're going to be talking about um, accounting for the entire impact of water on several examples. And one example is going to show how we can account for all the water that's required in making food. And the other example is about the water requirements for diapers, and to show that just accounting for all the water that goes into the diapers in the making and cleaning of diapers doesn't account for its environmental impact. So sort of two counter examples here. First, what I want to just review is that when we talked about environmental accounting on the first part, I gave a quick example for water. We'd want to look at the types of water, all the sources and the flow, the quality of that water, and then lump that in to decide what sort of information we need to make a decision. This life cycle analysis of water is all of the aspects of water used anywhere in the whole life cycle of the product, from the original creation of the product to the use and disposal. That's what we're looking at. So when we do that, we're looking at the water quantity, what are the sources and how much is needed, and then the water quality, so that sometimes after it's used, it's degraded so much that it can't be used for other things. And one of the things you're going to see about this life cycle analysis is that not all the water quality standards are the same or applicable in all situations. So it's context dependent, just like most of our environmental approaches. So first, let's look at the water that's embedded in food. And the water that's embedded in food means all the water that it's required in order to bring that food all the way to the consumer. So here's a pie chart for the water consumption in the United Kingdom, and 65% of the water use is embedded in food. Only a tiny sliver is in drinking water, the rest is in domestic uses and in industrial goods. So this is water consumption by the consumer. And see, like, a massive amount is embedded in food, and this is because, like we saw earlier, the amount of water required for agriculture is the highest water use in these economies. So one of the things we get from this sort of life cycle analysis of the amount of water it takes to bring a particular item of food to consumer's table is a chart like this that shows how much water was required. So for a pint of beer, 170 liters. That means every time you drink a pint of beer, you controlled the use of 170 liters of water in the production of that beer. Compare it to a glass of milk, 200 mils of glass of milk, only then 200 liters. So this comparison of which is high and low is probably as instructive as the actual number. But the other part about this, doing this accounting and creating this indicator of how much water was used, is it shows you what are the surprising water what are things in your that you consume that have a surprising amount of water. So you'd expect things like your potato, you got to grow the potato, it's 25 liters of water. But look over here. This is the champion hamburgers at 150 grams, or like a third pound hamburger, 2,400 liters of water. So I have a little diagram in this article, which is also in the reading, and you can get at it from these notes, about where all that water goes. So what they're going to do is take all the water to make a cow, and then how much beef comes from the cow, and then how many, divide that by how many hamburgers it could be made. And it takes over 15,000 liters of irrigation to grow the grain and to grow the grass and roughage that this one cow eats. Then it takes another 2,400 liters of water that the cow drinks, and another 7,000 liters of water that is going to wash the cow, all the other washing the stalls, that sort of stuff. And that makes one cow. So you have all this water going in to make one cow. Then out of that cow you get 200 kilograms of beef, and then you divide that total amount of water that was used there divided by how many hamburgers that 200 kilograms of beef would make, and the answer you get is 2,400 liters of embedded water per 150-gram burger. So this shows a huge amount of embedded water. Every time you eat a burger, you've you put a demand on the economy for 2,400 liters of embedded water. So this is a good type of life cycle analysis. Here's the burger, you work back all the way through all the different forms of water that it took to make that burger. So that's a life cycle analysis. The next one is a little bit more interesting in a sense, is we're going to start with the life cycle analysis, how much water it takes to do 6 months of diapering. So this is for 6 months of diapering for a little kid. If you use single use, that is disposable diapers, it's over 8,000 liters of water for 6 months. Cloth, then sent to a commercial laundry, almost 22,000 liters, and cloth washed at home, 18,000 liters. So the problem here is that summing it in this way really shows you the water use, but it actually hides some of the complexity and the differences in where this water depletion and where this water depletion took place. So first of all, let's look at the cloth that goes into the diapers. If just the amount of water that it takes to irrigate the cotton to make these diapers, that amount of water only counts for 10% of the home laundry budget, because most of that is for actually running the washing machine, but 47% of the commercial laundry budget, because that is there's water that goes into because their washing machines are just generally more efficient. But that hides this detail about where that cotton came from. If you have cotton that came from Mississippi, it only takes 850 liters of water to make 1 kilogram of cotton fiber. Even then, it's almost 800 kilograms of water to make 1 kilogram of cotton. Even then, that seems pretty excessive. But Mississippi, they grow the cotton on groundwater, surface and groundwater. It's not overdrawn. It's a humid climate. It's really where cotton grows well. But if you look at Arizona, it's almost 8 times as much water to make the same kilogram of cotton. And it's not only grown in the desert, it's water out of the Colorado, which we know is depleted, and it's drawing down aquifers. They're actually mining the water in order to make that cotton. So right there you have a 10-fold increase, and the source of the water that is being used is not renewable in Arizona, and it is renewable in Mississippi. Okay, similarly, washing. If you say single use, you only use a little bit just to wash up water. Home laundry, 90% of the water is used for the laundry, and in commercial laundry, it's again 49%. The rest going into the cotton production. But where you do that laundry makes a big difference. If you're in New York or Memphis, both of these are states that have a balance of water coming in versus the water going out. They use a small portion of the water flux through the environment. But in Los Angeles, they're water deficit. They divert water from all these other places wherever they can, where they can afford to send it, pump it, get it. And so if you do home laundry in Los Angeles, there's a huge difference compared to home laundry in New York. You're adding a huge water requirement right on Los Angeles in a place that's already water deficit. So again, this is this just example, just the water use in the diaper. Loss of water in the drying process, not a really big deal. The single-use diapers, the water for those comes from the water used in the pulp and paper production. Usually they don't irrigate the pulp forest, pulp tree forest, so it's just mainly in there. And again, we're not talking about this, but this doesn't show up in the water life cycle analysis. But a couple of those things, these other differences, for example, cotton, which you find in the home and the laundry diapers, is chemically intensive crop with a lot of leachate going into the runoff. The water laundry puts a demand on municipal sewage. This may not be a big deal in a well-functioning city, but in some places where the sewage and septic systems are stretched to the breaking point, this could be a big problem for local streams. And finally, where the pulp mills are and how they treat their effluents can make a big difference on local pollution of streams and rivers. So, for example, if this is well-managed pulp and paper mill and it's making this fiber like they are in the United States, this can be very good. But if you're buying this disposable diapers from some overseas company. Who knows? You'd have to study where that impact is taking place in order to understand whether this pulp mill is really more damaging than just the water. So from this example we saw, here's the water use just by type of diaper, but that we really need to back up through all this information that we used in the life cycle analysis to get a better handle on what the actual environmental impact is. All right, now a final point I want to make in this lecture is about whether water is a right for every person, and is it a human right that you're able to have a certain amount of water, or is it a responsibility? Now the point here isn't to reach an answer. My point of bringing this up is we know that water, clean water, drinkable water, is going to be a major stress on human populations across the globe. We saw, I mentioned before about access to water in South Africa. It's actually in the Constitution that they are guaranteed clean water for drinking. But there was recent riots over this because the water trucks didn't show up on time, and that people thought they were being diverted to other neighborhoods, those sorts of things. So there was riots and people were injured and killed. So this is a serious issue. Is it a right, or is it, or is it just another commodity? Well, I'm not going to answer that question here. There's obvious answers about values, and accounting can't answer those values for us. But what it can, and if you look at the diagram of what we want to do in accounting, is we need to observe an event, and we make a report, and then we provide that information for making the decision. So that point is, what information would you need to know to find out what water can be supplied to people? And then it's up to a more inclusive environmental problem to say, well, is this a right? Do they get this amount of water? Do they absolute right to it? It's a human rights violation if they don't get it? Or is it sort of a market failure that should be addressed with some sort of financial or economic solution? So that's a question beyond accounting, but accounting sets up what are the categories of water, where do they come from, what's the quantity and quality of water that we're talking about. Now in some countries the way they resolve this is maybe commercial supplies for water, but the contracts are written such that every household gets a certain amount of water right off the top for free, just for their own use, and then after that they have to pay for more water than that on some sort of metering system. So that's sort of a hybrid of what we're talking about. But my point here is that even if we're addressing a problem that sounds as charged as is clean water a right, we need to figure out, here's our multiple approaches. Which ones can we use to help get some information and help define this problem so that it can be solved? All right, that was it for lecture for this. That was the third part of this lecture.